Good morning, good afternoon, scholars. Welcome back to geometry. Today we are finishing up our circles unit, and we're going to do so with a concept called radians. Radians essentially is a method that mathematicians use to actually express portions of circles, sectors, and things like that. They use basically a comparison tool, a comparison method between the circumference and the diameter, or the circumference and a radius, to come about new systems of measurement. So today we're going to learn about this. What I'd like first for you to do is check out our sponsor for today's
Are
episode.
you a scholar looking to get a present for your teacher during this Teacher Appreciation Week? Well, you're in luck! From the people who have told you to read all directions and to show your work comes Spelling and Grammar Check. That's right, with just a few clicks, you can turn this poor, sad teacher into this happy educator. Get yours today and stop making silly mistakes.
I'd like to give a shout out to Mr. Ing for that. If you guys want any extra credit, please feel free to make your own videos with your friends, and I'll drop them in next time. To start off with our lesson today about radians, we're first going to talk about pi. We've seen pi, or the concept of pi, used in various equations like area and circumference. We also noted that it's like a ridiculously long number in terms of like set number 3.14159, yada yada yada, goes on for nearly infinity or presumably infinity. The way that this number actually comes about is through a method that relates to today's topic of radians. The number pi is actually equivalent in every circle, no matter the type of circle. If you take the diameter and then stretch it around your circle, in every single case, no matter what, there are going to be a pi's number of diameters for every circle, which is really cool. The other way that we're able to just show this mathematically, besides like testing it with a piece of string or trying to like peel apart a circle, is that if we just use that simple equation of circumference, where we say the circumference is equal to the diameter times pi, if we divide divide the diameter on both sides, we end up finding that the value of pi is equal to the circumference or diameter, or that there are 3.14159 diameters per every circle. Or if we're going to talk about a radius, which is our main focus today with radians, there's going to be 2 pi's worth of radii per circle. The way that we're going to set up our paper for today's lesson is we're going to look at this concept of radians in terms of 2 fashions. First, we're going to see how or what an actual radian is, how it's measured, how it comes about, and then we're going to go ahead and come up with an equation that allows us to convert back and forth between radians and degrees. What I'd like for you, or how for you to set up your page, or at least how I did it, I had my definition of radians and the concept along the top here. I'm then going to use a circle here to demonstrate what a radian looks like and how it moves around the circle, and then we're going to come up with an equation in the center. In total, we should have something that looks a little bit like this when we get through to the end. So, first, I mentioned previously that radians are a concept used specifically by mathematicians. Engineers frown away from it, artists, designers, they kind of remove themselves away from it and use either a system called gradients, which is more for engineers because it involves force at times, and then designers who use just the normal degrees that we typically see every day. For mathematicians, since they're using numbers that are nearly infinite in length at periods of time, they want to use and calculate and retain that unique value of pi for basically essentially like dire accuracy. The way that mathematicians came about this concept of radians, you can see that radii in the front of the word, is that they described one radian as being this relationship between the radius itself, as in coming from our center point out to our circumference, the actual physical parameters of the circle, and they take that value and then they place it going around. the circle itself. What I'd like to do is show you one example of an irradian. And what I have here is a piece of string that's equal to 1 radius length, and then I'm going to apply it along the circumference, or the arc length. So from here, I have my string, which I pre-measured out for us to use in our example. What I'm going to do now is basically just transpose it along the top and then just start marking off around. So what you'll notice is that you get a radian in terms of length is we have a pi related number that ends up going around. So for instance here, this little spot right here, we would call 1 radian in measurement. So we're kind of talking about an angle that comes out to here, and we're valuing this sector or section here. And instead of just using that term degrees, where we had 360, we're going to end up getting about 2 pi's worth of radians going around. So I'm just going to go ahead and begin to mark my way around here. You can do so on your piece of paper if you like, or you can get essentially like approximation. Slide my paper, produce another one. And we'll see here, get a little bit off. And one of the cool things here, that's this value right here. We're at about 3 radians in length. And if we go ahead and draw a line coming out, which would represent our diameter, or what you would call 180 degrees, we're just off the 180 degree mark. What's really cool about radians is that when we go about measuring them, 3 radians doesn't give us a diameter, but 3 pi, or 3.14 radians, gives us that value. We can say 1 pi radians is equal here. To 180. So when we're going to look at our equation up on the top in a moment or two, we're going to see a method that allows us basically to switch between the number of pi radians and the number 180 degrees, 2 different systems of measurement. So I'm going to go ahead and go from my 3 radian spot. I'm going to mark off my 4th radian, mark off my 5th radian, and next up I'm going to mark off my 6th radian. So you'll see as we come around here once again, my radius measurement around the circumference, we end with about 6 just there. Cool thing though is if we're going to consider that value of 360 degrees, which is right here, that's equivalent to 2 pi's worth of radians. Which is pretty nice. What you'll see mathematicians typically write this as, in terms of their concept, is as opposed to using the word radians, since everything is being placed in this concept of being measured in pi, and you're working with, say, within a circular field of mathematics, they already know that this concept's being expressed as radians, and they do not typically write the unit, as some people call it, down. Some mathematicians would argue that radians themselves are not a unit of measurement, since they're zero dimensional. It's more just like mathematical equation that you use or mathematical concept versus say something that's finite like an inch or a mile or a meter. All right, so this is how we present the concept of a radian going around. If we start to look at some stuff here, we can say, if we're going to add a little bit of detail, we have like our perpendicular radius would be around here or 90 degrees. Same thing, if we just draw back around, we're going to have around 270 degrees on the bottom left here. So what we're going to do now is look about how we actually convert this concept going back and forth. So when we're looking through our graph here, we can see kind of a relation developing. The notion of 360 degrees being equal specifically to 2 pi, as well as 180 degrees being equal to 1 pi radians. We can use this even calculation to kind of switch back and forth. So what I'd like for you to do to add to your notes is how do we switch back and forth? All right, so how do we switch back and forth? There's two different methods that we can use. Depends upon whether or not we are starting first with a degree measure. If we're starting with, say, a specific central angle of like 50 degrees, how do we then switch over to radians? What we're going to start here with is our degrees to radians. And to switch from degrees to radians, like how do we get from 180 to 1 pi? What we're first going to do is multiply. So first thing that we're going to do, if we want to go from degrees to radians, we're going to take that degree measure, multiply it by the number pi in our calculator, and then divide out the number 180. You'll see along the bottom here, 180 degrees. If we were to multiply that number, 180 times pi, then divide it by 180, extract that 180 value out, we'd be back to pi radians, or what we would say 1 pi radians. The same thing with 360. If we're going to multiply 360 by the number pi, so we have 360 pi, we then go ahead, divide it by 180, and we're left with a value of 2 pi. Okay, so next we're going to do is how do we go from radians to degrees? When we're working with radians and we want to go to degree measures, we're going to do essentially the opposite. We're going to take our value, multiply it by 180, and then divide it by pi. So what we're going to do first here, I'm going to give you an example. If we wanted to work with the number 180, for instance, where we have, say, a measurement of 1 radian, and 1 radian being that string length, that radius length. If we're going to go to degrees, we're going to do 180, or 1 times 180, and then divide it by the number pi. If we do 1 times 180, divide by pi, we get a value of about 57.2958. So if we want to calculate this value right here, we're already on our graph. We're told that we have a length, an arc length of 1 radian. We know that this section here would be calculated normal speak as 57.2958 degrees. You'll see in these particular examples how when we're working with, like, say, our extra credit assignment, and we have a lot of values that end up being worth something numerically in terms of pi, when we go ahead and convert out of pi, we get these super long decimal values. And that's why, just as like this example here, where we have a very, very finite and specific number that might not necessarily be easy to digest and calculate with or handle on a piece of paper, we use this concept for radians. So what I like to do is give another example here. If we had, say, 5.5 radians, 5.5 radians, and we wanted to go 2 degrees, we would multiply the number of radians by 180. So 5.5 times 180. You would take this value and then divide by the number pi. You end up getting a final solution, or where 5.5 radians is, at 315 degrees. So when we're working with radians, we're trying to refrain from having decimals if we're having these like very specific measured values. The next thing I want to show you here is we're going to move over, and now we're going to convert something from radians to degrees itself. Down here along the bottom, the number 270, what we're going to do if we want to convert that, we're going to take the value of degrees, 270. We then go ahead and multiply it by the number pi, and then we divide it by the number 180. So we're going to take that number 270, multiply it by pi, then divide out by 180, and we get a final solution of 1.5 pi. Or what you'll often see is written as 3 over 2. 3 divided by 2 is 1.5, or 3 over 2 pi. If we're looking at this logically as well too, if we know that 180 degrees is equal to 1 radian and 360 is equal to 2, we know that 270 degrees, which splits that semicircle in half, would be halfway between 2 pi radians and 1 pi radians, or 1.5 radians. In the same fashion, if we're talking about 90-degree value, all the way over here on the right, if we're looking to find something between 0 and 1 pi radians, our logical knowledge would dictate that we would have pi over 2 radians. Remember, when we're talking about this, we're talking about essentially this sector or section. How do we measure this section of the circle? There'd be pi divided by 2 radians. So one question for you. If we're somewhere around here, say like we're at the measure of 140 degrees, how many radians would that be? If we have 140 degrees, how would we go ahead and set up our equation? If we look up to the top here, and we're talking about going from degrees to radians, we're going to take that value of 140, multiply it by pi, divide it by 180, and we get a final solution, if you go through on your calculator, of 2.44 radians. All right, so for this concept, that's all we're pretty much going to go over together. What I'm going to have set up for you today is going to be a set of questions on Google Classroom that's going to allow you to go through and manipulate these values on a circle, like go from estimates to actual calculations. Just remember, this concept of radians is something that mathematicians are going to be using to calculate circles, and they're using that number pi because of its ability, as we saw in the beginning, to be expressed as this very neat and solid ratio between circumference and diameter. So why not use that method to also measure the different portions? It becomes much more easier to manage. If you have any questions, today is Tuesday. I will have my office hours from 1:30 to 3:30 today. Please feel free to drop by and ask any questions if you have them. All right. Have a nice day. Bye.